Hello, how are you, my dear students? Namaste to all. Today I am giving you a very interesting lecture about Kolbe's electrolysis, preparation of what you see, maybe alkane, maybe alkyne. So always we have some confusion how to write the preparation of alkane, alkene, alkyne. So I will give you very interesting tools. So what you see, Kolbe's electrolysis, electrolytic preparation, of alkane, alkene, alkyne. So very important for knowledge as well as what to see examination view of point. So first one is alkane. For example, ethane. So principle is like this. When electricity is passed through concentrated aqueous. Concentrated means high amount of compound. Aqueous means water. Concentrated aqueous solution of maybe sodium or maybe potassium salt of fatty acid. Yes. So we take, so for alkane, so for what is ethane, so you take very simple example like CH3CONA, that is sodium acetate. So what is the aqueous solution? So when electricity is passed through this solution, process is electrolysis. So after electrolysis, what we see? We get CH3CO plus Na. So in this case, we need two molecules. So better to multiply over here 2. So what you get? That is acetate ion. That is sodium ion. So we have to multiply over. So what you see in this case, doubling like Wurtz reaction. So you have already studied about the Wurtz reaction. So what we observe over here, so when electricity is passed through this sodium acetate aqueous solution, what we observe, we get acetate ion and what you see sodium ion. And what you see, that is what you say at anode. Always keep in mind. So maybe anode, maybe cathode. In electrolysis, 3. So in this case, as a electrolyte, what we use? As a electrolyte, what we use? Sodium acetate, anode. So at anode, always keep in mind, so oxidation process takes place. Oxidation process takes place. It means here loss of electron. loss of electron over here. So when always talk in mind. So when talk about the oxidation means always loss of electron. So what do you see? Anode means positive end. That is the positive end. So in this case, this state ion migrate towards, that is the state ion migrate towards anode. And here what you see, there is loss of 2 electron over here. So how many electrons? So loses 2 electrons, because how many electrons over here? 2 electrons. When you multiply by 2, so what is 2? It loses 2 electrons, so it becomes neutral. That is neutral. And after formation of this neutral, it decomposes into what is CH3 and 2 molecule of what you see, carbon dioxide. That is known as, always keep in mind, so always doubling. If 1 carbon, 2 carbon over there. If 2 carbon, 4 carbon over there. If 3 carbon, what you get? 6 carbon. Like what you see Wood's reaction. I have already told you. Yes. So what you see in this case? At anode there is formation of ethane. And what you see? 2 molecule of carbon dioxide. Yes. At cathode, always reduction process takes place. It means gain of electron over here. So in this case, loss of electron. In this case, what you see? Gain of electron. So these 2 electrons, what you see, revolve within the what you see electric circuit. So at anode, cathode means what you see, negative end. So at that point, 2 sodium ion migrate towards, migrates means attracts, migrates towards what you see, cathode. In this case, loss of electron, but in this case, what we see? Gain of electrons. So these 2 electron gain over here. So what we have? Plus 2 electrons. Yes. So after gaining 2 electrons, what it becomes? 0, neutral. We can say Na. That is the neutral sodium. Now we know the condition. The condition is what we see? Aqueous. So that aqueous Na react with water, and what we have? NaS plus S2. So what you see? 2Na. So how many hydrogen? 2 hydrogen. Okay. 1 oxygen over here. So what we have to do? Na. And what you see? S2O. So 2Na, 2NaS. So NaOH. So Na, S2. In this case, 1 S2. So what we have to do? 2Na. Yes. So in this case, 2S2O. Yes. So how many sodium ion over here? What is say 2Na? So we have to multiply over 2 there. So what do you get? Na reacts with water, and what do you get? Sodium oxide and hydrogen. So at anode, what do you get? Ethane. At cathode, what do you get? Hydrogen gas, and what do you see? NaOH solution. So as a whole reaction, we can write over here 2CH3CONA plus H2O. So what do we have? C2H6 ethane plus CO2 plus NaOH plus, that is the overall reaction. So when was say 2H2O, 2,6H6, CO2, 2CO2, 2NaH, yes, so that is the overall reaction. That is overall reactions. I think you have clear. So any alkane we can prepare. So and generally ask in examination that ethane. So we have to keep this reaction. So that is very important. So when asked in examination, write down the Kolbe's electrolysis for the preparation of alkane. So what we have to use? This one. Next one to preparation of alkene. Example is like this: CH2, that is known as ethane, or you can say ethylene gas. Yes. Now how can you prepare? So principle of this one is, when electricity is passed through concentrated, concentrated means a high amount, concentrated aqueous solution of maybe sodium, maybe potassium succinate, we get ethene gas. So that is the principle of this one. So look at over here. So what do you see over here? So succinate, CH2CONA, CH2CONA, that is the aqueous solution of sodium succinate. We can also use potassium instead of sodium. So when electrolysis process takes place, so what happens over here? So we get CH2, 0 means neutral, that is known as succinate neutral ion. And after formation of this, 0 means neutral. After making this neutral, after decomposition of this neutral compounds, what we have? CH2 double bond, that is known as ethene, that 2 molecule of carbon dioxide. So what do we get? CH2, that bond comes over here. So what do we have? Double bond over here. Yes. So that is so at first what we get? Succinate ion plus what to get? that is succinate ion. So you know, at anode oxidation takes place. It means loss of electron over here. So what do we see? CH2 negative charge, CH2 negative charge. So what do you see? That migrates towards, migrates means attracts, migrates towards anode. And going there, so how many electrons over here? 2 electrons. So it loses 2 electrons, minus means loses. So what we have? CH2, now no charge over here, 0, 0 means neutral. And after formation of this neutral compound, it decomposes itself. And what do we have? CH2, that bond comes over here. So what do we have? CH2 double bond, CH2 plus what? See, 2 molecule of carbon dioxide. Yes. Next one is at anode. Now what to say at cathode. So here reduction process takes place. It means gain of electrons. What we have? 2 Na positive charge. So it migrates towards what is the cathode, and going there it gains 2 electron. So that loses electron, that gains by what's the cathode. So what we have? 2 Na neutral. Yes, and that neutral sodium reacts with water. So what we have? Sodium hydroxide plus hydrogen gas. So what we have? Na, how many H? 2 H, 2 H, 2 O, 2 Na, 2 Na, that is balance. Yes. So what you see at last? Overall reaction is like this. CH2 CONA, CH2 CONA plus H2O, same. So what you see? What product is over here? What product you get? CH2 double bond CH2, that is known as ethane. 2 molecule of carbon dioxide, 2 molecule of sodium hydroxide, and what you get? Hydrogen gas. That is the overall reaction. Yes, so that is about what you see? Ethene. Now third one is what you say? Third one is like this: formation of alkyne. For example, is it better to write? For example, what you see? CH, that is known as ethane, that is also known as acetylene gas. Yes, general formula you know, Cn twice n minus 2. Yes. So principle is like this. Principle is like this. When electricity is passed through concentrated aqueous solution of sodium, or we can say potassium maleate, or we can say fumarate, that is also known as organic compound fumarate, we get what we say ethine gas, for gas. So, what we see over here, when electricity is passed through what is sodium, so maybe we can take potassium CH CO potassium double bond CrCOK, that is potassium maleate or fumarate, better to write maleate, that is cis form, that is the trans form. So, must be aqueous solution. So, when electrolysis process, so what we have, negative charge plus potassium, that is known as maleate, maleate ion, or you can say fumarate, fumarate ion. Yes. So, what we see, at always at anode, you know, oxidation process takes place. Oxidation process takes place, it means gain of what is the loss of electron over here. So, what you see at anode, so that is the negative charge over here. So, what we have, CH double bond CH, negative charge, so it migrates towards anode, and going there, what we see over here, it loses 2 electrons. What we see, minus means loses how many electrons? 2 electrons. So, when it loses 2 electrons, what we see over here, CH double bond CH neutral, means that is the neutral maleate. So, after decomposition, it decomposes itself, and what we have, CH triple bond plus what you see, we get what you see 2 molecule of carbon dioxide, that is known as ethine. Yes. Next one is what you see at anode, what is at cathode. So, what you see, 2 potassium ion, so migrates towards what you see, cathode, and going there, what you see, it in this case loses, in this case gains 2 electron over here. So, both positive charge cancel out, and what we have, neutral, that is the neutral potassium, and that is the what type of condition over here, aqueous. So, that K react with water, So what you get? KOH plus, so when you balance 2K 2S, yes, that is the balance chemical equation. So overall reaction is like this. Overall reaction is simply we can say, so what you see, CH potassium, maybe we can keep what you see sodium over here, plus 2H2O. So what product you get? CH, that is the ethyne, plus 2 molecule of carbon dioxide, plus 2 molecule of what you see potassium hydroxide, plus what you see hydrogen gas. That is the overall reaction. So what you see, so for always keep in mind, for alkane what we have to use, sodium or potassium salt of what you see acetate, and for what you see alkene what we have to use, sodium potassium succinate, and what you see for alkyne what we have to use, sodium potassium fumarate, or we can say maleate. So I think, so by this method we can prepare alkane, alkene, alkynes. In examination ask you, how can you prepare? How can you prepare what you see alkane, alkene and alkyne by Kolbe's electrolytic reduction process. In 5 marks, this question asked. If you ask 5 marks, sometimes ask in 2 marks only. That is the first question. Question 2, how can you prepare alkane or alkene or alkyne by Kolbe's electrolytic reduction So I think you can prepare anyone, maybe alkane, maybe alkane, maybe alkyne. I sometimes ask you in full mark, 5 marks. So write down the preparation of alkane, alkene, and alkyne. So you have to, I think you can write all these because I have already given you all the reaction clearly. So I think you have clear knowledge about the Kolbe's electrolytic reduction of what you see sodium acetate, what you see sodium succinate, and what you see sodium maleate or fumarate. So you can ask in the examination. If asked in examination, you can write easily, I think. So thank you for watching this video, nice video, and next day I will come with next video. Today's